Hello everyone, and welcome back to exercise number 31 of the SolidWorks Basic Tutorial series. In this video, we're going to be designing a hooked weight. Now, as always, in implementing this part within SolidWorks, we're going to be using many of the SolidWorks features, namely the extrude boss base feature and extrude cut feature. But also, we're going to be using the revolve cut feature to create this counterbore feature, and more importantly, the swept boss base tool to create this lifting hook. Here we see the schematic drawing for exercise number 31. All dimensions here are in millimeters. And we see that we have the isometric view, the front view, and the section view. And this section view is along this line, the section line BB, okay? And actually, we can model this within SolidWorks in 4 main steps. Step number 1 involves creating this cylindrical body. And to do that, we see that we need to draw a circle first on the top plane, and then use the extrude boss base tool to create a thickness, or the height of the cylinder. Step 2 involves creating this recess or counterbore feature. We could either create that using by drawing circles on the bottom face and then using the extrude cut tool, or more simply, we could use the revolve cut tool, as we will see later on in this video. Step 3 involves working on these rounding out these top edges, this top edge and this bottom edge of the cylinder, using the fillet tool. Finally, step 4 involves creating this lifting hook, and for that we need to use the swept boss base tool. So we begin by creating this sketch representing the profile of this lifting hook. And then we're going to extrude a circular profile with a diameter of 8 millimeters along this nonlinear path. And also in this video, I've discussed or explained the difference between the standard extrude boss base feature and the newer or more organic tool. In this case, it's a swept boss base tool. And specifically, the swept boss base tool allows you to extrude 2D profiles along a non-linear path. In this case, we're going to be using it to create this profile of this lifting hook. Okay, so the steps involving creating this component basically correspond or coincide with the number of features for the component. We have this cylindrical body, we have this counterbore feature at the bottom, we have the fillet wedges or fillet edges, and we have the lifting hook. So 4 main steps. Okay, so with that aside, let's get started with exercise number 31. Okay, so we start by creating a new SolidWorks part. We set the background to plain white, and we copy exercise number 31 into SolidWorks. All right, so as I said previously, we can model this in 4 main steps, and step number 1 involves creating this cylindrical body. So to do that, select top plane, sketch, select circle, and starting from the origin, we draw a circle. From the figure here, we see that this cylinder should have a base diameter of 70 millimeters. So on your mouse, click your right mouse button and move your cursor upwards to activate the Smart Dimension tool. And assign a diameter of 70 millimeters for the circle. Now we need to extrude this circle to a height of 60 millimeters. So on your keyboard, press S, and then select Extrude Boss Base. Go ahead and assign an extrusion height of 60 millimeters, and then select OK. Step 2 involves creating this recess or counterbore feature at the bottom, and we can do that actually in 2 ways. We could either select this bottom face and draw 2 concentric circles, and then use the extrude cut tool twice, or we could use the revolve cut tool, which is a lot easier. And to do that, we need to sketch out the profile of this counterbore. And we notice here that we have symmetry along the y-axis, so it's sufficient that we only draw 1/2 and then use the revolve cut tool to basically create the counterbore feature. So select right plane, sketch, and notice here that the right plane divides the cylinder to 2 equal halves. And that's one of the advantages of actually modeling your component with respect to the origin. It maintains symmetry. Anyway, so select line tool, and from the origin here, let's sketch out half of the counterbore profile, like this. Okay, so now select Smart Dimension tool, and from the figure we see that the entire length of this edge is 40, half of it should be 20, so this edge should have a length of 20 millimeters. This edge should have a height of 6. The distance between this top edge and this bottom edge should be 10 millimeters. And the length of this edge should be 3 millimeters. All right. Now we need to use the revolve cut tool, sorry. So go to features and then select revolve cut. Here it's going to ask you for the axis of revolution, and here we're going to select this vertical line. And we see a preview of what the cut process is going to produce, right? A very clean counterbore feature, and then select OK. That completes step 2. Step 3 involves rounding out the edges of the cylinder, specifically the top and bottom edges. So select fillets, and from the figure we see we have a fillet radius of 2 millimeters. So go ahead and assign a fillet radius of 2 millimeters, and then select this top edge and this bottom edge, and then select OK. So that creates the main cylindrical body of the component. Finally, we leave the best for last, and in this case, it involves creating this lifting hook. And as I said previously, we're going to use something called the swept boss base tool right here. And the difference between the swept boss base tool and the standard extrude boss base tool is that the extrude boss base tool extrudes 2D sketches in a linear fashion, whereas swept boss base tool extrudes 2D profiles in a non-linear way, right? And in this case, we need to extrude this circular profile, this shank, along this non-linear path, which represents the shape of this hook. So step 1 here involves creating this hook shape. So select right plane, sketch, select circle, and starting from the origin here, move vertically upwards and draw a circle, right? Set the relation between this center of this circle and the origin as vertical, okay? Select Smart Dimension, and we see here that this circle should have a diameter of 30 millimeters. So go ahead and assign a diameter of 30 millimeters. The distance between the center of this circle and this top edge should be 25. So the distance between this point and this edge is 25 millimeters. Let's connect this circle with this top face by drawing a vertical line starting from this point all the way to the midpoint of this top face, right? Now select center line, and let's draw a center line, or a horizontal center line starting from the origin of this circle. And let's draw another center line, this time at an angle, all right? And let's set the angle between these two lines as 15 degrees. Okay, select trim entities, and let's delete this extra line. Select fillet radius, and here we're going to fill out this sharp edge, and from the figure we see that we have a fillet radius of 5 millimeters. So go ahead and assign a fillet radius of 5, and then select this point, and then select OK. Okay, so that creates the profile of this this lifting hook. Select OK, exit sketch. All right, so that completes phase 1. Phase 2 is that we need to sketch out the circular profile of this shank. So what do? We select this top face, sketch, select circle, and starting from the origin here, we draw a circle. Very small circle. And the thickness or the diameter of this shank should be 8 millimeters. So activating the Smart Dimension tool, we're going to assign a radius of 8 millimeters. Now go to Features, Swept Boss Base. And here we see that it's going to ask you for the 2D sketch you want to sweep along. And by default, it's already selected the circle that it created. And now it's going to ask you for the path. Like you want to extrude this circular profile along what path? And we're going to select this sketch. See, we have a preview here, and then select OK. So that creates the lifting hook. Now what's left is that we need to fill out some certain sharp edges. So select fillet, assign a fillet radius of 2 millimeters, and we're going to fill out or smooth out this sharp edge and this sharp edge right here. And then select OK. Delete this image, assign material. You can select any material, just select ASI 1020 steel, apply, close, and let's change the color of this hook weight. Let's change it to orange. Let's change the saturation here. Set the view to perspective, and that completes exercise number 31. Thank you all so much for watching. If you have any comments or questions, please write them down below. Also, please don't forget to like and subscribe to the channel. I'll see you all in exercise number 32. Until we meet again, bye-bye.